Hello, welcome back to the continuing lecture series in investments. Now, we're moving on to the new chapter, new topic, which is efficient diversification. Actually, this is not really a new topic. It's actually the continuation of return and risk, but now we're focusing more on the allocation between risky assets within the risky portfolio. Okay, in other words, remember from the previous topic and previous sessions that we talked about the basically the weight allocation, right? Weight allocation between risk-free asset and risky portfolio, right? And the weight was defined as Y, which goes into the risky portfolio. Now then, what assets constitute the risky portfolio? What assets? Of course, broadly, there are two types of assets, two types of instruments that make up risky portfolio, right? Risky portfolio, right? Two types of assets, which are basically what? Stocks and bonds, right? What goes into the risky portfolio? Stocks and bonds. And then our next question is, in what proportion, by what weight? I mean, how much do we put into stock and how much do we put into bonds, right? What would be the optimal allocation of our funds between stocks and bonds, right? First, we allocate between risky-free assets and risky assets, right? So in the risky portfolio, now it breaks up into two categories, stocks and bonds. So if the weight distribution previously was, let's say we put, 60%, right, into a risky portfolio. Now, our question is, so that means 40% goes into risk-free, right? Risk-free portfolio. Now, our next question is, how is our 60% going to break up into stocks and bonds? Again, if this is let's say stocks for 40%, bonds, that means there will be 60% in the bonds. And actually, you will get that's out of the total, right? Out of the total complete portfolio, right? Weight of the complete portfolio, right? Which is 1, right? Out of the total is going to be 6 times 4, so that's going to be 0.24, 24%. And this is going to be 36%. Right? Makes sense. This type of weight distribution or weight allocation, right? Weight distribution. This is, and our question is, what's the optimal? Right? Is this 40% into stocks and 60% into bonds? Is that optimal? I mean, this is optimal. I mean, in a complete portfolio, we found optimal weight in complete portfolio, right? We found optimal weight in the complete portfolio within the risky portfolio. Within the risky portfolio, right? Within the risky portfolio, right? Is this optimal weight? Is this optimal, right? That is the question. Now, so that's what we're gonna do in this, this new chapter. Okay. So basically, starting from, we all understand that the risk basically, the total risk comes from two sources, systemic risk and non-systemic risk. Okay, systemic meaning it's coming from the economic system, right? So it is non-diversifiable. In other words, the systemic risk doesn't go away by diversification, whereas non-systemic risks can be diversified away. Okay, it can be diversified away. So it's a diversifiable risk. Diversifiable. And and also, I mean, that's what basically you learned in Finance 100. Stock portfolio, stock portfolio's risk can go down drastically, go down through diversification because non-systemic risks are firm specific, right? Or two sources of firm specific risk. One is financial risk. The other one is business risk, right? They can be all diversified away because they mathematically, saw that also in Finance 100. Firm specific risks can cancel out each other, will offset each other when the diversification, when the portfolio is well diversified. And what is the when we say well, it's just a qualitative word. It's an adverb, actually, qualitative word. So what is the quantifiable threshold for well diversified? Actually, there is a consensus. I mean, empirical consensus. Empirically, when you have about 20 assets or more, if you have about 20 assets in your portfolio, of course, 20 assets means 20 different industries, pretty much 20 different industries, right? They have to come from 20 different industries, right? Otherwise, there's no diversification. I mean, 20 companies from the same industry, and there's absolutely no diversification, right? And the firm-specific risk, when we have, about 20 different industries in the portfolio, the firm-specific risk drops drastically, right? But that's not the total risk, right? Total risk basically, right? Total risk comes from systemic risk and non-systemic risk. They also sometimes call systematic. The word is being used interchangeably, although semantics, in terms of semantics, they are different. But there is, originally it was called systemic because it's, coming from the market system, macroeconomic system. But later, it also started to mean, the systematic component in the risk. So now the word is being used, interchangeably. Now, also, if you remember, in bond, right? Even in lending, there are firm-specific risk and systemic risk, right? Why? What are those? Remember, there are like 5 risks in bond, basically in lending, right? First of all, the most significant and most direct threat or risk in lending is default risk. Isn't that right? Default risk. And then, obviously you are, concerned that if you're a lender, right, you're concerned about the, default risk of your borrower. That's the biggest concern. That's why you're looking at, the credit rating. Now, second, there is liquidity risk. Liquidity, right? How how well accepted is this company by the market? How well is this company accepted by the market? In other words, the bonds of a less known company will be less liquid and less marketable, right? So that's liquidity risk. But these two are basically, firm specific, right? But what's another risk? Inflation risk. Inflation, right? And the inflation risk is, macroeconomic. Isn't that right? It's systemic because it comes from the macroeconomic system. There's nothing you can do I mean, of course, in bond, you factor in inflation risk premium, risk premium. Again, what I'm saying is, it's coming from the macroeconomic system. It's not firm specific, right? And then what else? There is interest rate risk, right? Which is also, you know, uh, systemic, because interest rate is, we all know, it's not a firm specific thing. It's the entire macroeconomic system, right? That comes from, that is originating from the macroeconomic system. So it is, and interest rate risk also entails reinvestment rate risk, right? Reinvestment rate. Reinvestment rate, it's also, I mean, when the interest rate goes down, obviously, you will have lower return from reinvesting your coupon payments, right? And that also exactly applies the same to the stocks as well, because you're reinvesting your dividends, right? As the interest rate goes down, you suffer from reinvestment rates. And in case of bond, maturity risk, maturity risk and price risk are also connected with interest rate risk, right? So it's kind of systemic, right? Also in the stocks, I don't want to go over this Finance 100 material all over again, but as for systemic risk, there are 4 sources of systemic risk, right? Which are, of course, interest rate, right? Interest rate risk, inflation, right? Reinvestment rate, right? And exchange rate, right? Basically, an overall market, a financial market, right? Overall, a stock market, a shock in the stock market. Whereas, diversifiable risks, they are generally financial risk, form specific, so it's financial risk. In other words, this means leverage, debt ratio, right? Too much debt, right? And business risk. This is, literally very firm specific business risk. The nature of, the industry, the nature of the business, right? So this is nothing new. We all know that the when you have about, empirically, when you have about 20 different industries, diversified by 20 assets coming from representing 20 different industries, then your non-systemic risk drops drastically, and that's where let's see. And then from there, it doesn't go down even if you increase your number of shares. It's truncated because it doesn't go down any further, significantly further, right? So that's the thing, that's why about 20 assets, and it's well diversified. Okay. Already, well diversified. Yeah. But that's only non-systemic risk, right? The market risk or the systemic risk still remains because diversification doesn't do anything to market risk, right? Diversification doesn't do much to the market risk. And so to understand further, how best, what would be the best, weight, or optimal weight, right? Between risky assets, we'll have to understand the concept of covariance and correlation. And of course, correlation is everything. And think about it. When you have the reason non-systemic risk goes down this drastically is because the correlation between the assets in the portfolio, right? Correlation between I and J, right, is either negative. If it is negative, it will be perfect, very low, or something like correlation. And I and J are not only two assets, for all that means for all I, that's not J. Okay, what that means is think about it. If there are n assets in your stock portfolio, n stocks, n company, n number, let's say n is 20. Each, so stock number 1, stock number 2 is INJ, right? Stock number 2 and stock number 3 is also INJ. Because 1 and 2 are not the same, 2 and 3 are not the same. Of course, then 1 and 3 are not the same. All INJ that are not equal, right? The correlation between the two respective assets are either negative or between less than 1 or greater than -1. In other words, small numbers, right? Very low numbers. Not just less than 1. It should be, better be, but anyway, if they are all, if they are perfectly, if I and J, stock I and stock J are perfectly negatively correlated, what does that mean? The correlation between I and J is -1. Then, they will completely cancel out each other, right? Once again, this is something we did also in, 100. So I'm not going to go over that again. So the Greek character rho is the symbol for covariance. And of course, correlation. Covariance is basically it's like a common variance between asset X and asset Y. Okay, common variance, right? So what is variance? What is the symbol for variance? Symbol for the symbol for variance sigma x squared. Symbol for variance, right? And what does that mean? Standard deviation squared, right? This means standard deviation squared, right? Okay. And covariance is what? Instead of, if you have, that's, variance of x. And if you have variance of y, what would it be? What would it look like? Of course, variance of y would look like, right here too, yeah. Variance of y would, that, which is also, standard deviation of y squared. Standard deviation. Okay. Then think about it. Instead of, standard deviation of x times standard deviation of x, or instead of, standard deviation of y times standard deviation of y, if you simply, if that's variance, if you simply, find a common variance between the two, then it will be covariance, right? And it will be written as standard deviation of x. Oh. Times standard deviation of y, that's covariance. Okay. Okay, that's covariance. And in our here right now, X, you can understand X as stock portfolio and Y as the bond portfolio. Okay, and if there is correlation between the two, yeah, and usually stocks and bonds would have a negative, slightly negative correlation, and oops, as I said, our question is, oh, it was, I wrote it here, right? We already we understand the already how to find the optimal weight in complete portfolio, and then in risky portfolio. Now we need to find optimal weight distribution between stocks and bonds, and inside the stock portfolio. Then again, of course, inside the stock portfolio, right? There will be some of n and stocks, right? And so the again, there will be weight issue, right? So if you have n stocks, then by what proportion? That can be discussed later. Further discussed. So that would be where is it? Weight of I times, right? And the same thing, bonds, right? Will have the same issue. Weight of J. We'll have this kind of finding how much. Okay. So for now, just quickly, so we know this is the portfolio expected return, which is a weighted average, right? Weighted average of asset X and asset Y, right? I mean, consider this X, consider this, right? Okay, because and consider this a stock, consider this bond, right? And then covariance is basically, I already explained, a standard deviation of and basically, remember how we found, a variance, when there is no probability. So normally it would be, the difference term of X and difference term of Y. In this case, difference term of stock, difference term of y, and sum of all of them over n minus 1. If there is no probability, right? If the probability is all the same, right? And that would be the case. I mean, in other words, if you think about how very crude for example, variance of x, we have, two ways, very crude of course, using, probabilities, right? P of I times xi minus x bar squared. X bar is the, of course, mean. But if it is not by probability, what do you do? I forgot to put sum there, but so I'm gonna have to rewrite it. Sum all the difference terms xi minus x bar squared, right? Over n minus 1, right? And I'm going to have to rewrite this. But, our time is up. So let me, almost, I'll have to rewrite it. I'll put equal sign here and call this variance. Variance from x, right? So you get the idea of covariance. You simply substitute this, right? This term by another, difference term in another variable. So we're gonna continue with this in the next video because we have already exceeded first 30 minutes. So I'm gonna have to cut the video, and I will see you guys in the next video. Stop recording.